All right, this is what you will see when you open up the PLCfiddle.com website. This is very basic for ladder logic programming in comparison to some other programs for ladder logic programming. Maybe a bit clunky, but it works, and it works well for online programming. So up here at the top you have several tabs, and these are items that you can place in your program. Here is your program and the rungs, the ladder rungs of your program. Now again, ladder logic programs scan from left to right and from top to bottom as fast as the PLC can scan. So let's look through here. Under contacts, we have contacts, and I can grab one of these and drag it down and put it in place, like so. Under coils, we have coils, and I can grab one of these and bring it down and put it in place. Under math, there are few mathematical operations, not a whole lot. Under compare, you can use some greater than, less than, and equal to, or not equal to options. Here under time, you have on delay timers, off delay timers, and countdown, and so on. And then other. This other tab is important. You can save if you would like to. You can add a rung. If I click that, just adds a rung down here. This is to put in a branch. So if I grab this and drag it down here, it puts that branch in. It doesn't look very useful, but now I could say grab this and drag it to the other side, grab this, place it inside there, come back to contacts, grab another contact, and put it down there. Some ladder logic programs don't have branches on the output. Sometimes that is not recommended. However, this will allow you to put branches on the output and put two different coils in there. If you want to remove something, simply come to Other, grab what you want to remove, and take it up to Trash. And I can even remove an entire rung if I want to. And then over here, you have your controls and things you have stored in memory. You have booleans you can put in memory, numbers you can put in memory, timers you can put in memory, and counters you can put in memory. And again, this is simplified, but it works. So let's look at the program that you start up with. This is very common. 2 push buttons and a motor. If I click the start push button, it is now pushed down with my finger. If I let my finger off, click again, and this would turn off. And you notice what has happened. This has been turned on, the stop button is not on, and so power went from left to right through and started the motor running. Once the logic bit for the motor running was enabled, power can then branch around here and keep the motor running. So this is now latched on. If I click the stop button and click that back off, it's now off. So on, off. This type of contact is called a normally open contact. This type is called a normally closed contact. And if you think about this, at least if you're like me, you can get confused fairly quickly. For me, the easiest way to understand this is just to write a simple program like this and start playing with it. You'll notice here that the stop button is off, and therefore this normally closed contact is on. When I turn the stop button on, this normally closed contact is off. So if you think about it this way, this contact is doing the opposite of what this button is doing. These normally open contacts are open until I click the start button, and then it closes. All right, let's go ahead and get started. We're going to add to this program. This program turns a motor on and off. I want a warning indicator flashing light so that when the motor is running, the light is flashing. To start with, I want to add some items to the memory of the PLC. The first one is in fact a Boolean, so I can leave this at Boolean, and it is the light. Now if you want credit for these, be sure to add your initials after any memory items that you put in there. Add. There's light and my initials. Now you can delete these. For example, if I want to delete this start button, I push this X, it doesn't actually delete because it's being used in the program. But if the memory item is not being used in the program, I can delete it. Now I just need to add it again. There are two more items I need to add in the memory, and they are both timers. I'm going to call them T1 and T2. I also need two more rungs so that I have a total of 3 more rungs in here. All right, now let's go to time and count. I'm going to add 2 on delay timers. One there, one there. Let's go to coils. I'm going to add a coil here. So this on delay timer is T1, this on delay timer is T2, and this coil is the light. Now let's go to contacts. I'm going to add a normally closed contact, a normally open contact, and another normally open contact. All right, now let's look at these on delay timers, T1 and T2 over here. I'm going to drop those down. This has PRE, and that is what I preset that timer to count to. So each of these timers, this is measured in seconds. Often timers are measured in milliseconds, or you can select what you like. These are seconds. I'm going to set each of these to half a second, 0.5 seconds. Click the little blue check mark. Come down here, half a second. Click the little blue check mark. ACC is what the timer has timed up to. Q is the output of the timer. So timer 1, when there is flow from left to right here, timer 1 turns on, it counts up to half a second, and then it sends an output. And the same with timer 2. Once timer 2 is turned on, it will count up to half a second, and then it will send an output. And Q is that output. Up here, the variable for this normally closed contact, I'm going to set to timer 2 Q. The variable for this normally open contact, I'm going to set to timer 1 Q. And for this light, I'm going to set this to timer 1 Q. And so we now have our flashing light. I'm going to minimize these timers over here so it's not as distracting. And you can see that our light is cycling every second. On for half a second, off for half a second. But this is not what I want. You notice that if I turn the motor off, my light is still cycling. But I want this to only happen when the motor is on. So that's as simple as grabbing another contact and putting it in the way of the light and setting this to motor. Now, the motor is off, the light is not flashing. If I cycle this start button, the motor is now on and the light is flashing. All you need to submit for this assignment is a screenshot that shows your program and your memory items. So I would take a screenshot, probably something like this.